Number 6 in your homework is asking about the p-value, and you're actually going to have to go further in your hypothesis testing and draw a conclusion. So let's start with part A. It says identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. So again, this is giving us our test statistic, so we don't have to find it, and we're going to use it for the claim that p does not equal 0.435. So that's our original claim. The opposite of that is p equals 0.0435. So when you go to step 3, which is write the null hypothesis, the null hypothesis is always the one with your equals. And then your alternative hypothesis is the not equals or the less than or greater than. And then you're going to want to put a little star by your original claim. So this time our alternative is our original claim. Now step 4 is where you identify if it's two-tailed, left-tailed, or right-tailed. And that depends on your alternative hypothesis. If you have a less than, it's going to be left-tailed. If you have a greater than, it's going to be right-tailed. If you have a not equals to, it's going to be two-tailed. And if you think about your normal distribution, less than would be the shaded to the less, greater than would be greater than that critical value, and then two-tailed would be where you have both tails are symmetrical. So our first question is just asking what tailed it is. Because of the not equals, we're two-tailed. Now the next part says find the p-value. If you look at your steps, your p-value, you can usually use StatCrunch, but that's only if it gives you the correct information, which would be your number of successes and your sample size. This case it doesn't. It just gives you the test statistic. So you need to use, you can use the normal calculator on StatCrunch, which is what we did in the last section, where you can use your calculator to find the probability. So there's a few things I need to point out to you, mostly because this is two-tailed. But they do give us our test statistic. It's 2.91. That's what you're going to use in your StatCrunch. So we're going to go to StatCrunch. And you do stat, calculators, normal, because we're doing probability. Now our test statistic was 2.91, so it's going to be over here on the right. So we need to do the probability that it's greater than 2.91. Which is just giving us this, you can barely see it, but it's this little bit of area over here, the 0.0018. Now, because it's two-tailed, I not only have that area, but I should have the same area over here. So I need to double this probability. So it's going to be 0.0018 times 2. Which is going to give me, sorry, 0.0036. So my p-value is double the one tail. And you only do that when it's two-tailed. If it was left-tailed, you'd put the z-score right here. If it was right-tailed, you'd put the z-score right here, and it would just be the probability of each tail. But if it's two-tailed, you need to double your p-value. Oh, it only wants 3 decimal places, so 0.4. Okay, now this part C is the reason why I've been doing steps 1, 2, and 3, because that's where you decide to fail to reject and then your conclusion statement. So remember, p-value method, this is step 7 right here. You compare your p-value to your significance level. If your p-value is less than or equal, you reject the null. If it's greater than or equal to your alpha, you fail to reject the null. So in this case, my p-value is 0.0036, and if I look back at the question, my alpha is 0.01. So this is the p-value, and this is the alpha. This is greater than 0.01. Oh, it is not greater than. It is less than. So we are going to reject the null hypothesis. Okay, the second part of that is that if you reject it, you've got 4 conclusion statements. You've got reject, fail to reject, reject, fail to reject. But the first part is, where was the original claim? Back here, where we originally wrote them, we starred where the original claim was in the alternative. So our claim is found in H1, and we've rejected the null, so there is sufficient evidence to support the claim.